determine resistance when you know the power in watts and the voltage in volts. You can use a specific formula derived from Ohm's law and the power equation. The formula you will use is R equals E squared divided by W, where R represents the resistance in ohms, E represents the voltage in volts, and W represents the power in watts. Let's break down this formula and its application. Firstly, understand the components. Resistance, measured in ohms, is the opposition to the flow of electric current in a circuit. Voltage, measured in volts, is the electric potential difference that drives the current through the circuit. Power, measured in watts, is the rate at which electrical energy is transferred or used in the circuit. Now consider the relationship between these components. Ohm's law states that voltage equals current times resistance, or E equals I times R. The power formula states that power equals voltage times current, or W equals E times I. By combining these two formulas, we can derive the formula for calculating resistance when power and voltage are known. To derive the formula, start with the power formula W equals E times I. We need to express the current I in terms of voltage E and resistance R. From Ohm's law, we know that I equals E divided by R. Substitute this expression for I into the power formula, so W equals E times E divided by R, which simplifies to W equals E squared divided by R. Now, rearrange the formula to solve for R. Multiply both sides of the equation by R, giving R times W equals E squared. Then, divide both sides by W, giving R equals E squared divided by W. This is the formula we will use to calculate resistance. Now, let's apply this formula to an example. Suppose you have a device that consumes 100 watts of power when connected to a 120 volt power source. To find the resistance of this device, we plug the values into the formula. R equals 120 squared divided by 100. First, calculate 120 squared, which is 120 times 120, resulting in 14,400. Then, divide 14,400 by 100, which equals 144. Therefore, the resistance is 144 ohms. It's crucial to understand the units of measurement to ensure accurate calculations. Voltage must be in volts, power must be in watts, and the resulting resistance will be in ohms. If any of these values are given in different units, you will need to convert them before applying the formula. For example, if power is given in kilowatts, you would need to convert it to watts by multiplying by 1000. Similarly, if voltage is given in kilovolts, you would need to convert it to volts by multiplying by 1000. Understanding the limitations of this formula is also important. It assumes a purely resistive circuit, meaning that the circuit only contains resistance and no reactance such as inductance or capacitance. In circuits with reactance, the relationship between voltage, current, and power becomes more complex, and additional formulas and calculations are needed to determine the impedance and power factor. The formula R equals E squared divided by W is applicable to alternating current, AC, circuits as well as direct current, DC, circuits as long as you are dealing with purely resistive loads, and root mean square, RMS, values for voltage and current in AC circuits. In more complex AC circuits involving reactive components, you need to consider impedance instead of just resistance and use more advanced power calculations. It's essential to use appropriate safety precautions when working with electrical circuits. Always disconnect the power source before making any measurements or adjustments. Use properly insulated tools and equipment, and follow all applicable electrical codes and regulations. If you are not comfortable working with electricity, it is best to consult a qualified electrician. Let's go over some additional examples to solidify your understanding. Example 1 involves a heating element. A heating element in a toaster is rated at 800 watts when connected to a 120 volt power supply. What is the resistance of the heating element? Using the formula R equals E squared divided by W, we have R equals 120 squared divided by 800. 120 squared is 14,400. So R equals 14,400 divided by 800, which equals 18 ohms. Therefore, the resistance of the heating element is 18 ohms. Example 2 involves a light bulb. An incandescent light bulb is rated at 60 watts when connected to a 120 volt power supply. What is the resistance of the light bulb? Using the formula R equals E squared divided to W, we have R equals 120 squared divided by 60. 120 squared is 14,400. So R equals 14,400 divided by 60, which equals 240 ohms. Therefore, the resistance of the light bulb is 240 ohms. Example 3 involves a motor. A small electric motor consumes 200 watts of power when connected to a 24 volt direct current DC power supply. What is the resistance of the motor? Using the formula R equals E squared divided by W, we have R equals 24 squared divided by 200. 24 squared is 576, so R equals 576 divided by 200, which equals 2.88 ohms. Therefore, the resistance of the motor is 2.88 ohms. These examples demonstrate how the formula R equals E squared divided by W can be applied to various electrical devices to calculate their resistance. Remember to always use the correct units and take appropriate safety precautions when working with electricity. Now, let's discuss some common mistakes to avoid when using this formula. One common mistake is using the wrong units. Always ensure that voltage is in volts, power is in watts, and that you are solving for resistance in ohms. If the values are given in different units, convert them before plugging them into the formula. Another common mistake is confusing power with energy. Power is the rate at which energy is transferred or used, while energy is the total amount of work done or heat generated. The formula R equals E squared divided by W uses power, not energy. Another mistake is applying the formula to circuits with reactance without accounting for impedance and power factor. This formula is only accurate for purely resistive circuits. In circuits with inductance or capacitance, you need to use more advanced calculations. Let's explore some practical applications of this formula. Firstly, circuit design. Electrical engineers use this formula to design circuits with specific resistance values. For example, they may need to calculate the resistance of a resistor needed to limit current in a circuit or to create a voltage divider. Secondly, troubleshooting. Technicians use this formula to troubleshoot electrical problems. By measuring voltage and power, they can calculate the resistance of a component and compare it to its expected value. If the calculated resistance is significantly different from the expected value, it may indicate a faulty component. Thirdly, appliance repair. Repair technicians use this formula to diagnose and repair appliances. For example, they may need to calculate the resistance of a heating element to determine if it is functioning properly. Fourthly, electrical safety. Electricians use this formula to ensure electrical safety. By calculating the resistance of grounding conductors, they can verify that they are adequate to safely carry fault current. Now let's delve deeper into the concept of impedance and its role in AC circuits. Impedance, denoted by Z, is the total opposition to current flow in an AC circuit. It includes both resistance, R, and reactance, X. Reactance is the opposition to current flow caused by inductors, inductive reactance, and capacitors, capacitive reactance. The formula for impedance in an AC circuit is Z equals the square root of R squared plus X squared. In a purely resistive circuit, the impedance is equal to the resistance because the reactance is zero. However, in circuits with inductance or capacitance, the impedance is greater than the resistance, and the current and voltage are no longer in phase. The power factor, denoted by cosine phi, is the ratio of real power, measured in watts, to apparent power, measured in volt-amps. In a purely resistive circuit, the power factor is 1 because the real power is equal to the apparent power. However, in circuits with reactance, the power factor is less than 1 because some of the power is reactive power, which does not do any useful work. The power factor is used to calculate the real power consumed by an AC circuit. The formula for real power is P equals V times I times cosine phi, where P is the real power in watts, V is the voltage in volts, I is the current in amps, and cosine phi is the power factor. Now let's discuss some advanced topics related to resistance, voltage, and power. Firstly, temperature coefficient of resistance. The resistance of most materials changes with temperature. The temperature coefficient of resistance is a measure of how much the resistance changes per degree Celsius or Fahrenheit. Some materials have a positive temperature coefficient, meaning that their resistance increases with temperature, while other materials have a negative temperature coefficient, meaning that their resistance decreases with temperature. Secondly, voltage drop. Voltage drop is the decrease in voltage along a conductor due to its resistance. Voltage drop can be significant in long conductors or conductors with high resistance. It is important to minimize voltage drop to ensure that electrical equipment receives the proper voltage. The NEC, National Electrical Code, specifies maximum allowable voltage drops for different types of circuits. Thirdly, power dissipation. Power dissipation is the amount of power that is converted into heat in a resistor or other electrical component. Power dissipation is an important consideration in circuit design because excessive power dissipation can damage components. Resistors are typically rated for their power dissipation capability. Now, let's explore some additional resources for learning more about resistance, voltage, and power. Firstly, textbooks. There are many excellent textbooks on electrical engineering and electronics that cover these topics in detail. Secondly, online courses. There are many online courses available that teach the fundamentals of electricity and electronics. Thirdly, websites. There are many websites that provide information on electrical concepts, formulas, and calculations. Fourthly, professional organizations. Organizations such as the IEE, Institute of Electrical and Electronics Engineers, offer resources and training for electrical engineers and technicians. The formula R equals E squared divided by W is a valuable tool for calculating resistance when you know the power and voltage. By understanding this formula and its applications, you can design circuits, troubleshoot electrical problems, and ensure electrical safety. Remember to always use the correct units, avoid common mistakes, and take appropriate safety precautions when working with electricity. With practice and experience, you can become proficient in using this formula and other electrical calculations.